Hello friends and welcome to AS Education. In this video we are going to see the section of solids and development for a pyramid. Like last video we have seen how a prism can be cut with the help of AIP, that is auxiliary inclined plane, and then we have shown the true shape of the section and the development of lateral surface. So in today's video we will see the true shape of the section and development of lateral surface for the pyramid. So friends, let's start with the problem here. A hexagonal pyramid, 30 mm side of base and 70 mm axis height, is resting on its corner on HP. This pyramid is kept on HP but in such a way that its corner point should come on right hand side. So friends, here you can see this pyramid is kept on horizontal plane but it is kept in such a way that its corner point is coming on right hand side point. If you are going to tilt this solid on right hand side, it should tilt on its corner point, not the edge. It is cut by a section plane inclined at 60 degree to HP and passing through a point 30 mm from the base on the axis. So friends, here you can see we are going to cut this pyramid with the help of this AIP, which is making angle 60 degree with the horizontal plane, and it is passing through at a distance of 30 mm on the axis line from its base. So we are going to cut this solid with the help of this AIP, and then we'll be looking at the section so that we can get the true shape of the section and development of lateral surface. So if you see here object, you can see the section here. That is what apparent shape of the section can be seen in the top view. But if you are looking at perpendicular direction to the section, you will be getting the true shape of that section only. So apart from that, we'll be projecting or we'll be developing the lateral surface. So whatever the surface retains here, that surface we are going to open it so that the development of lateral surface can be seen. So friends, let's start with the problem in AutoCAD. Very first of all, we'll take the projection layer and using line command, we'll draw the XY line. Now we'll be getting this true shape of the hexagon that can be seen in the top view. Now everything that we are going to draw in the top view and front view, that can be drawn with the help of projection layer only. So at the end, the removing part can be kept as a projection only, and retaining part we can dark with the help of continuous layer. So here I am going to draw the hexagon using polygon command. Number of sides 6, enter. Just right click there, click on edge, click the first point and then drag the mouse and give distance 30, enter. While dragging the mouse, make sure that you are dragging that mouse on right hand side. I'll just move it downward. So friends, this is what the top view we are getting. Now as it is a pyramid, all slant edges can be seen in the top view. So we'll join all these opposite corners with each other so that the slant edges can be seen here. And accordingly, we will name these points like this is the apex point O and these are the corner points 1 to 6. So here we get these namings to each and every corner and the apex point. Now we'll take projections of all these corner point and apex point till this XY line first. Search perpendicular point. Now once it is drawn, we can draw the projection in front view. As we have been given the total height is 70 mm. So I will draw the axis line as 70 mm with the help of projection layer only. So all these points in the front view will be joined with the apex point. So very first of all, we'll name all these points. That 1 will become 1 dash, 2 and 6 will become 2 dash and 6 dash. O will become O dash, 3 and 5, 3 dash, 5 dash, and 4 will 4 dash. Now once you get all these points, corner points in front view, you can join these points with O dash. Now friends, as per the given problem, you can see here the section plane is making angle 60 degree with HP, but it is passing through a point 30 mm from the base on the axis. So very first of all, we'll measure 30 mm on the axis line from the base. So I'll draw a line here with the help of center line. I'll draw a line here first of all. Now this line is supposed to be moved by distance 30 mm, as in the question it is given. The cutting section plane is passing through point which is 30 mm away from the base. So this is a point where we are getting the point on the axis line through which cutting plane will be passed. So using center line only, we are supposed to draw a cutting plane or section plane at an angle of 60 degree to HP. Make ortho of, press tab key, use 60 and enter. So friends, we have just drawn here section plane. The section plane is supposed to be extended on another side as well in the same direction. So guys, you can conclude here that the left part is supposed to be removed, while the part which is majorly resting on HP, that part is supposed to be retained. So we will take outline or a continuous layer, and using line command, we'll complete all these lines. From 2 dash 2, it will come directly to 3 dash, as there is no point at this center point. There is no slant edge at midpoint over here. Then the slant edge will be continue till section plane. Again from 4 dash towards the direction of O dash. So this right part is the retaining part, and we are getting a section on this surface only. Now all these points on the section are supposed to be projected downward in the top view. So for that we need the points which are being cut with the help of section plane. So you can see here, as the section plane is cutting the base, there must be 2 points we should get on front surface and on back surface. So friends, here you can see we are getting 2 points A dash B dash on base, as the section plane will be cutting the base at 2 points. Similarly, the section plane is cutting the slant edge at 2 points C dash and D dash, because there are 2 slant edges, O dash to 2 dash and O dash to 6 dash. So that's why we are getting 2 points over here. Similarly, we'll be getting 2 points again because of the 2 slant edges, O to 3 and O to 5. Again, single point G dash on the slant edge O dash to 4 dash. So this way we can name these points. So friends, so ultimately we will be getting the section surface between the given points here. Now we'll try to project all these points vertically downwards in the top view. So as you can see, A dash B dash is cutting the base, so it will come on the perimeter. C dash and D dash is coming on the slant line. So we'll try to project this C dash and D dash on O to 6 and O to 2. Like that we'll be projecting other points as well. So we'll take projection layer, line command, and from every point in the front we will draw projections vertically downwards in the top view. The point should not get catch anywhere in the diagram, so just extend beyond the lines. Once you obtain all these projection lines, now get the projection of these points in the top view. Like I'm getting A dash B dash on the base. So on the base means on perimeter I'm going to get point A and B here. So I'm getting point A and B on this base. So we have projected A dash B dash vertically downwards in the top view, but it should be on the perimeter as it is cutting the base. Now this is the projection line of C dash D dash, but C dash D dash is coming on the slant edge, O to 2 and O to 6. So we'll project this C and D on O to 2 and O to 6. So after projecting these points C and D in the top view on slant edges O to 2 and O to 6, we get points C and D respectively. Similarly, we'll be trying to project this E dash and F dash on O to 3 and O to 5. So after getting all these points in the top view, we'll be joining these points with the help of dark line. So go to the continuous layer, take line command, join all these points from point A onwards. This is what the section we are getting in the top view. It is just projection of this section surface. So we'll be showing the hatching lines between the surface here. So for giving this hatch command, we'll turn off this projection layer first, and then we'll go to the hatch. In the hatch, you can choose ANSI 31, select the area and close it. Then go to the layers, turn on the projection layer. This is how it will look. Now, as you know, the right part is the retaining part, whereas the left part, which is including this apex point, is what is the part which is being removed. So from the front view, it is clear that this left part is being removed, while the right part is to be retained on the surface. So with the help of continuous layer only, we will take line command and we will dark the right part. So it will come with all these slant edges. Now guys, as you can see, the line is not visible because of the projection layer. Just do right click, click on the isolate project, and then do undo so that the line will be visible to you. Now take line command again and complete the remaining lines. So friends, this is what sectional top view we obtained here. As the section plane is not parallel to horizontal plane, this section surface is not the true shape. So to obtain the true shape, this line or this section plane must be perpendicular to some another plane. So we'll create that reference plane which will be parallel to this section plane here, for which I will just copy this line at some random distance because of at some random distance, so that this plane I can consider as any reference plane which is parallel to this section plane. Now if you're going to project this section surface with respect to this reference plane, we are getting the true shape of that section only. So for that, we have to project all these points of the section A dash, B dash, C dash, D dash, and up to G dash straight away up to what? This reference plane. So we'll take projection layer, and with the help of line command, from point A dash, B dash, we will draw the line which will be perpendicular to this XY line here. So this is what projection layer I have drawn for point A dash and B dash. Similar projection line can be drawn from point C dash, D dash, A dash, F dash, and G dash. Just copy these points. So that now the projections line are prepared up to this reference plane. So in this case, we are supposed to project these points beyond this reference plane as well. But the measurement are supposed to be taken from the top view for each and every point. As we are continuing with A dash B dash line, which must be beyond this reference plane, but the measurement will take from the top view. Change the projection layer to the continuous layer. Dimension. From this XY line, I will measure the distance of A, point A in the top view. Similarly, I will take measurement from XY line till point B. So two measurement we are getting here. One is 44.9 for point B. Second is 88.8. So we'll take this projection layer here. So we'll draw the line first of measurement 44.9 with the help of projection layer from point A dash B dash only, because right now we are projecting A and B. So while drawing this line, you have to maintain the same direction. Just make sure that now the 30-degree line is maintained here and give distance 44.9, then enter. So this is like the extended part of this line only. So we are getting point B here. Once you obtain B, now go to the point A, which will be at a distance of 88.8. Take line command. Again, we are supposed to extend this line. So in the same direction, I will draw the line of length 88.8. Then enter. So at a distance of 88.8 from XY line, we are getting point A. Now this is all about point A and B. We can remove these dimensions as it is not required now. Now it's time to project point C and D. So we'll take measurements from the top view. Take dimensions from XY line till point D. We are getting 43.2, and till point C we are getting 90.4. So we'll draw the 43.2 first from point C dash and D dash. Projection layer, line command. 43.2 we want to draw. 43.2, where we will be getting point D, and at a distance of 90.4 we are getting point C. So take line command from XY line only on the same projection layer. Maintain the direction, give distance 90.4, enter. Here we are getting point C. Now similarly we can project point E and F. We don't need these dimensions. You can remove them. Continuous layer, dimensions from XY line till point F. We are getting 56. So we are getting point F at a distance of 56 and point E at a distance of 77.7. Change the layer to the projection, line command from point E dash and F dash in the same direction. The first length will give 56. Enter. Here we'll be obtaining what? Point F. Similarly, at a distance of 77.7, we'll get point E. So now we'll try to project point G from XY line. Which we are getting 66.8. So from this point G dash, beyond this reference plane, we'll draw a line of length 66.8. Here we get point G. Now you can join all these points with the help of straight line, as it is a pyramid. So we'll be joining these points with the help of straight line. Go to the continuous layer, line command between the point A to B, then B to D, F, G, E, C, and then A. This is what the true shape of the section we have just obtained. So we are supposed to show hatch line as well. So just turn off the lines, projection layers, go to the hatch, choose NSI 31, give area, close it, again turn on the projection layer. Now you can name this part as true shape of the section. So friends, this is how we can project the true shape of the section, any solid that has been cut by section plane. Now we'll try to develop the lateral surface of this pyramid, which will be different than that of what the prism which we have seen in the last video. So very first of all, we are supposed to draw the slant edge, which must be a true length. So to develop this pyramid, we must develop the pyramid in the projection layer first, because the retaining part and removing part will do it later, for which I need a true length of the slant edge first. Then we have to decide whether O dash to 4 dash is a true length. So you have to look into the projection in the top view, O to 4, whether it is a parallel to XY line or not. So in the top view, you can see O to 4 is parallel to XY line. So of course, O dash to 4 dash would be a true length. So go to the copy command, select this edge from the XY line. So copy this O dash to 4 dash, right click, do left click on the XY line and place it on XY line at some random distance. So from this part onwards, we are going to project this point. So friends, now we'll be projecting these points. Now this is one slant edge through which we are going to develop the pyramid. So friends, this is a slant edge. So you can name any point, whether it is O to 1, O to 2, O to 3, whatever the points you can name. We have named here O to 1. Now we'll try to how to project this pyramid. If pyramid is open, the lateral surface of the pyramid is open, it will be developed in a path of circle only, because one point is the apex point and at the base we are getting the polygon. So it will be developed during on the path of what? Circle. So we'll change the layer to the projection layer, take circle command, and from point O to 1 we'll draw a circle. Now on this path, circular path only, we'll be developing this pyramid. So friends, to get the polygon on this circular path, we have side of base 30 mm, which is given in the problem. We can show the dimension as well here, that is 30 mm is the side of base. So this side of base of 30 mm is supposed to be drawn here on the circular path 6 number of times. So to draw 30 mm length straight line on the circular path, we will take the help of circle command, and from point 1 we'll draw a circle of radius 30 mm each 6 times. Second circle, I am going to start from this point as a center, give radius 30, enter. So two circles have been made. This is 3. This is fourth circle of 30 mm radius. This is fifth. This is sixth. As we are going to get 6 number of sides, we have drawn 6 circles here. Now, using line command, we will draw the straight lines between all these points. Now friends, with the help of circles, we have drawn the 30 mm side of base on this circular path. You can check the dimension using this aligned dimension between the 2 points, whether it is 30 or not. Once it is done, now you can delete these circles which are not required. Also, we don't need this outer circle as well, so you can delete that circle as well, because we have obtained all the points of this polygon. Now, with the help of line command, you can join each and every point there with the apex point. Now, like O to 1 we have just developed over here, so other points 2, 3, 4, 5, 6 can be given over here. So friends, here you can see O to 1, O to 2, O to 3, 4, 5, 6, and again we are getting point 1 because we have opened this pyramid through any slant edge. Let's say from O to 1 we have opened it. So O to 1 will be appeared on both sides. To get the section points on this developed surface, you are supposed to draw straightaway projection layer till this O to 1 line. We are supposed to draw projection from each and every point on the first line, that is O to 1. So take line command from point G dash, make ortho on, draw a line till it just intersects O to 1. From point E dash to F dash, draw a line till it intersects the O to 1. Also from C to D, draw a line till this O to 1. Also AB is lying on XY line only, so it is coming to directly 1 only. Now the second projection line between the projected surface can be drawn with the help of circle command. So friends, you can draw a circle between point O and the intersection point O to 1. So how many points you are getting on O to 1, you can draw a circle between them. So now I will just trim these unwanted lines, like this circle is not required here. So you can see here one projection line from G dash, it is rotating through the projected surface. Like that E and F, it is projecting through developed surface. Again C to D, this is like rotating on its developed surface. So we'll just remove the unwanted part of the circle. So now it is also projected throughout its developed surface, and AB is still on its base only. Now we'll try to project all these points in the developed surface. As you can see, G dash is lying on O to 4 dash, O dash to 4 dash. So this is the projection line of G, and on O to 4, so at this point we are going to get point G. So we have just marked point G on the same projection layer on a line O to 4. Like that, E dash and F dash, these are the points which are lying on O dash to 3 dash and O dash to 5 dash. So on this projection line, between the line O to 3 and O to 5, we will mark E and F respectively. Similarly, you can project point C and D, which is on O to 2 and O to 6. So this is the line projection line of C and D. So on line O to 2 and O to 6, we'll get C and D. So friends, we obtained point C, D, E, F and G. Now to get the point A dash and B dash, which is lying on base, as you know, this base, it is projected along the base only, but at what location we are going to project, that measurement can be taken from the top view. So we'll be measuring the distance of A and B from point 1. So let's say I want to project point A first. So point A is lying on 1 to 2. So this distance 1 to A is supposed to be measured between the line 1 to 2, for which I will draw a circle to take the measurement between 1 to A. And this circle I'll place between the line 1 to 2. So I'll just copy this from point 1. We'll place from point 1 on in between 1 to 2. So here we get point A. So between the line 1 to 2, we got point A here. Similarly, we can obtain point B. Just like point A, B is lying at the same distance from point 1, but it is lying between the points 1 to 6. So we'll just copy this circle from point 1 and we'll place this between point 1 and 6. So here we get point B. So this is just point B we have obtained. Now you can delete these circles which are not required. Now we are supposed to draw the line joining all these points. Go to the continuous layer, take line command from point A to C we have just draw a line joining the section points. As we can see in the front view, the part involving apex point is being removed. So this part is supposed to be removed, only right part is supposed to be retained. So we can dark the base which is not involving the apex point. Go to the line command and join these points B to 6. But also this is not a cone, this is a pyramid. So all these slant edges can be seen as a dark lines. So friends, here we have just completed section of solids and development of lateral surface of pyramid. I hope you understood how to develop the lateral surface of the pyramid now. So friends, once you develop this lateral surface of the pyramid, now you can give the remaining dimensions. Now we can give the dimensions also. The height was 70 mm and the section plane which was passing through the point on the axis line, that was at a distance of 30 mm from the base. The edge of the base we have just shown over here. So this is how we get the true shape of the surface and get the development of lateral surface of pyramid. Now friends, in this example the pyramid was kept on one of its corner point. It was resting on corner points. So instead of that, if it is given edge, how it can be drawn, you can practice such kind of problems, whether it is given that solid is resting on corner point or it is given resting on side of base. So accordingly, we are supposed to draw the polygon in the top view and we'll be completing this section of solid, getting the true shape and getting the development of lateral surface. So that's all about this section of solids, and thank you.